Okay, so in this session, what we're going to do is we're going to work through bit by bit a linked list, and we're going to build up from creating a node and then creating a list, and then adding functions like insert and front, insert back. So the way we're going to do it then is the same as in the previous sessions, where I've got some code written out here in the main script, which should be able to run and demonstrate everything working. The only problem is none of the classes exist. So what you've got to do, as almost a side exercise as well, is look at a section of code, work out what the class is, what parameters it has and what functions it has, and then build that up. So you're kind of both learning the linked list, but also learning to decode, or back engineer, sorry, what's going on here. So when we look at this code, which is available on the Teams page, you can see that I've split it up into different sections, section 1, 2, 3, 4, etc. Follow these sequentially, so uncomment them as you go along, make sure this one gets working, and then you move on to section 2, and they usually use what you built in the previous section. So don't delete anything in between. So if we start by running, first off, it's going to fail, as we'd expect, because list node doesn't exist. So we know the first thing we need to do is build this list node. Now, if you remember from your lecture notes, list node contains two properties: the data, which is stored within that node, and the next node, which it's linked to. So nodes are always sat next to each other, and you want to hop from one to the next one to the next one to the next one. So nodes are always linking to their neighboring node, or the sequential one. So to start off with, though, we're going to create a constructor which just sets data and next to null. Okay, so just to summarize that, to make it a bit clearer, you need to create a list node class that has two properties: data and the next node property, and then a constructor inside that. So one function, which is a constructor, which sets both of those to null because it's given no parameters, and then a second function which converts that to a string. So the string should just print out the data. Now there's a few things you need to work out before you start coding that. You need to work out what data type is your data going to be, like what's a variable type, and also what variable type your next node property is going to be. Think about that. So pause the video now, and give yourself a couple of minutes to try and work through it, and then resume the video if you're getting stuck or want to check what you've done is correct. Okay, so I'm now going to explain the solution to it. So first thing, we need to create our class. So let's get doing that. This is called a list node. We're not going to inherit anything. And we said there were two properties. First off, we had data, and we had the next node. So data, well, obviously it depends on what we're storing, but this is where polymorphism comes in, because what we can do is we can just do the highest class there is in terms of hierarchy, and just say object. This way we can store any kind of class that we like within that variable. The exception here would be primitives. So primitives wouldn't be able to store it in that, but as you'll see later on, Java handily casts it to an object when we need it to, which is nice. Anyway, so that's our data one, and then we also have to do our next node. So this is a bit weird actually, because we're creating a class called list node, and we need to somehow point to another list node. So we have to almost use the class that we are creating. And that may seem weird, but it's perfectly valid. It's, I think, like self-referential or something like that. It's in the lecture notes. So we might do list node and then next. So now we have our two properties. That's fantastic. But we also need to create those two functions. First off, and the most important, is the constructor. So public list node. And in this instance, we're not receiving anything. So what we'll do is we'll set data and next to null. Okay, so the final function we need to implement is that toString function. So this will be public. It's returning a string. It's called toString, no parameters. First thing we need to check is if it's null. So if data is equal to null, then we return empty. Otherwise, we will return data.toString. Now, of course, this is assuming that the data object has a toString function, which in Java is a safe assumption, as long as it's an object. So let's go back to our main. Let's run this and make sure that we're working. Okay, good. So as we're expecting, we're getting some empty list. Well done. So now we move on to section 2. Let's uncomment this code. And let's work on what's going on. So we're going to add a constructor that accepts any object type and the next node. So let's walk through this then to understand what we actually need to be able to do. So we're going to create our last node in the list. And that's going to store in a string. And because it's the last node, then we don't want to point to a next node. We're just going to set it to null so that we know we're at the end of the list. Then we're going to create our first node, again using new list node, and our data is going to be an integer, and we're going to point to the last node which we just created. So that's why, confusingly, we created the last node first and the first node last, because we needed to have that last node to exist in order to link to it. So what we're doing here is we're almost creating a list using nodes, but we're doing it in a very inefficient, bad way, okay? Because we're not using a class. What we're doing is we're creating two nodes and we're linking one to the other. Very simple. And what also it's showing is how we can have different data types stored inside our data because we had that general object class. So again, then we do our toString function. That's already implemented. So the only thing left really to do then is to implement that constructor, which takes some generic data and a node. So again, I'm going to pause the video. Pause the video and just have a play around, see if you can add that constructor. Think carefully about what data type your parameters are going to be. Okay, so I'll pause now, and then we'll give you the answers. Okay, so hopefully you've had a go and run the script and see if it works. If not, let's walk through the implementation. So we'll open up list node. We already have one constructor, which is null, but now we're going to add a second. This time we actually do accept parameters. The first parameter we accepted was the data. What data type, variable type should that be? Well, object. It allows us to accept any incoming class in Java, which is nice. We'll call that new data, and then also the next node. Now this could be null, remember. That's perfectly fine. We'll be able to handle it. So very simple, data is equal to new data. That's storing the data that we've just received into our property. Then we need to set the next node to equal the next node which the constructor has been passed. Very simple, just 3 lines, 4 if you include the bracket. So let's run that. What we're expecting to see? Well, we should see printed out under section 2, 2 different list nodes with their content in there. Let's see if that's the case. Oh, we've got an error because I have done list nodes, which is not quite right. Let's go again. God. Good, fantastic. So section 2, we're printing 34 and high. Now, a slight subtlety here. I said earlier that we're accepting object. An object is a class. But 34, an integer, is not a class, is it? It's a primitive. So that's interesting because what it shows us is that the compiler is converting that 34 to one of the primitive wrapper classes. So it's essentially doing, without you knowing, new integer. Now if we run that, okay, well, it's fine. We're not Java nerds, so we don't care about that depreciation. Okay, good. Still runs perfectly fine, but essentially it's just doing that kind of not really casting, but it's wrapping the data type for you. Good. So if you've got to here, what you've been able to do is to create two list nodes and link them to one another. Now that's really nice, and you're almost very close to building the list. So I'm going to leave the list, which is section 3 and section 4, into a next video. So take a break, play around with those nodes, create loads, connect them all together, and just have fun. I think the most important thing to understand here is the notion of linking the nodes. So what happens if maybe as an exercise now, you try and insert a node in between these two. So I create these two, print them, and then I try and insert a new one. Now that's a bit tough because we have to try and avoid losing references to the other nodes. Anyway, so have a go, play around with that. Once you're comfortable with the nodes and you understand what they are, then watch the next video on lists, which is detailing section 3 and section 4 here.